Okay, let's start with number six. What is the least common denominator in number six? 35. Great job, 35. Okay, so times 35 times 35 times 35 times 35. Remember, you have to be fair to everybody. You have to multiply everybody by 35. Is there really only one letter in this problem? All right. 2765 divided by 35. Okay, now I'm going to combine like terms. Okay, I got 22 fifths. Did you guys get 22 fifths? I hope you got 22 fifths. Somebody, okay, good. Any questions about number six before we move on? I would just like to say that it fits so satisfyingly perfectly in that space. Don't know why that matters, but it does. Also, have you seen the extremely large amount of fractions in number eight? Looks fractiony, very fractiony. Okay, I don't think it's too bad though. What is the least common denominator for number eight? 24. At least that's not too bad to figure out. I have to multiply a lot of stuff by 24 though. Yikes. Did I miss anything? Okay. Holy smokes, got a lot of things in it. A lot of stuff. Things and stuff. Stuff and things. Many terms in this equation. Okay, combining. So I'm gonna combine these two and these two. Hmm, I guess that's it. It was a weird answer. Doubting myself, but the fraction ones just end up like that sometimes. The other one was nice. Hey, you guys, when you're done with your warm-ups, please grab your notebook. So today we're doing one problem in our notebook, this one, and then the rest of our problems are in our packet. So you only have to draw this one, and then the rest of them are all drawn for you, luckily. Um, but I need to teach you how to do it first, so you're gonna do this then. And for these notes, I'm going to use two colors. So if you're somebody who likes to color your notes, I'm also going to use pink. I'm going to use pink and blue. Okay, everybody. So this problem is much more about vocab than it is about math. So this is like a, I don't know, seventh grade sequence problem. I'm sure that you guys can all see that they're going up by 4 each time. That's not really, I mean, it is, but that's not really what we're here to do. We need to change this into a math one problem, and that is this vocab. So I think the vocab is much more difficult than the actual problem. So I'm going to try to go slow. First, can you all tell that it's going up by 4 each time? Okay. So we all say that, we all know that, but now we need to use common language when we're talking about that. So on the resource page, that's going to be called a sequence generator. Sequence generator. And the letter that we use is D. Okay. I'm hoping that at least one person in the class is like, no, it's N. If anybody said in their mind, the slope is 4, that is a correct statement, and I like it. It's good. It's just that this is linear, but it's not a line. Okay, let me say that again. It's linear, but it's not a line. We don't connect the dots. It's just the dot, and that's called discrete. So your dots will line up in a pretty line, but we don't connect them. So they don't really have a slope. They do, but they don't. Okay. So D stands for difference, which means that they all have 4 between them. The difference between all of them is 4. If you have a sequence that is going up each time, the difference will be positive. And if you have it going down each time, it will be negative. And you'll be able to see that it matches the slope of what the line would be if we had sketched the line. Okay, so most important thing, the growth is adding 4 each time. So D, the common difference between them is 4. And if you want to think in your mind the slope is 4, that's totally okay. It's just that it's not really a line. It's just dots in a line. Okay, the next thing we're going to talk about is this, N and T of N. Okay, so what does this stuff mean? N is the spot that the number is in. So in your other color, if you're doing another color, put N equals right underneath your numbers, and then put a little baby 1, 2, 3, 4, 5. This is saying that -9 is in the first spot. -5 is in the second spot. -1 is in the third spot. Okay, so let's read this. This is spot number 1, and this is going to be term 1. T stands for term. So first term is -9. This is very easy, but it's just the vocab. So this is saying this is the first spot. This is term 1, which is in that spot. Okay. Spot number 2, the term is -5. Spot number 3, the term is -1. Spot number 4, the term is 3. Spot number 5, the term is 7. And then I bet you guys know what to do from there. So what's the next one? Spot 6 would be 11, and spot 7 would be 15. Okay, so you might think to yourself, it kind of looks like this problem is saying X and F of X. That's true. I am saying kind of X and F of X, which is Y, basically. But it's just because it's not an actual line, it's just the dots. We use different notation. Like when Patrick, no, it was SpongeBob, he was gonna go to the tree dome. Anybody know what the tree dome is? He was gonna go to the tree dome and he was gonna have tea with Sandy and it was gonna be fancy. And Patrick was like, when in doubt, pinky out. This is just fancy notation. That's all it is for very easy math. So please don't get like anxiety about the words. You know how to do all the math. It's just connecting that to the vocab at this point. Okay. Now over here, this is also the next easiest part. You're going to graph these points, but do not connect them. So 1, -9, 2, -5, 3, -1, 4, 3, 5, 7, And we're just going to stop there. On the resource page that we do in a few minutes, you won't be able to fit all of the points on your graph, and that's okay. Just fit the ones we can fit. Okay, but it's really important to me that you see that it makes a line, but we're not going to draw the line. And we're going to leave it as dots. And this is called discrete, which means we're leaving the gaps. Okay, so we figured out the sequence generator is D in this problem. It's not always D. I'll go over that in a second. We figured out the table. We figured out the graph. Okay, now come down here. We're going to do some defining. Sequences are number patterns. You guys have been doing number patterns since kindergarten. I remember my little kids coming home and counting by twos, and they were super excited about it in kindergarten. And they have like these little plastic bears, and they'd be like 2 bears and then 4 bears, and it's great. Okay, now this is the part where we need to sort of connect what we know to what we're learning right now. Linear equations are y equals mx plus b. That is not shocking. Okay. Linear equations make arithmetic sequences. This word is not arithmetic. Arithmetic is a verb. Arithmetic is an adjective, which means that the dots make a line, basically. Okay, so I want you to take this and we're going to translate it to notation that we use for sequences. So T of n equals, so that should kind of remind you of like f of x equals the growth, which is D, sequence generator, so that's going up 4 each time. And then the letter we use is n, because that's the spot it's in. Plus, okay, now this is going to be weird, and we need to spend a minute on that. What is B in a line? Just a regular old line. What's B? Y-intercept. Okay. So here's the thing. These don't really have y-intercepts. This number, term 0, does not really exist. However, we're still going to use it in our equation. So take your other color, make an arrow going back, and I just put a line here to show that it's not really there, but we're still going to calculate it for our equation. Okay, what would term 0 be in this problem? What would the number in front of -9 be if there was a number? -13. Okay. And we call that term 0. I really want you to see that these two things are the same thing. This is just regular, fancy, regular, fancy. This is when there's a line. This is when there's dots that make a line shape. Okay, now we're going to go back to this and write. First, we're going to say this is arithmetic. Why is it arithmetic? Because my dots are making a line shape and it's going up by 4 each time. And we're going to write our equation. Okay, so it's going to look like y equals mx plus b, but it's going to have these symbols instead. So T of n equals, okay, the growth is 4 n plus term 0 is -13. Just like y equals mx plus b. It just got different letters in it, which means that we're not connecting the dots. Okay, so sequence generator is the growth. N is the spot the number is in. T of N is the number in that spot. Okay, now this problem is really done. However, we don't just have linears anymore. If you remember from your foldable, now we also have exponentials. And exponential equations look like this. Y equals AB to the X. So for our notes, we need to come back in and figure out what the equation would be for the sequence that is formed by repeated multiplication of the same thing, which is geometric. So linears make arithmetics, exponentials make geometric. So it's just going to be that curve. Do you guys remember the curve? Does anybody remember the curve from the foldable? Okay. Or the bunnies or any of that stuff. Okay. So this looks like T of N equals. So that's the Y. A is the start, which is going to be term 0. B is the multiplier, and we haven't had one yet, but it's called R. R stands for ratio, like how much they multiply to be each other, and then N is the letter that we use. Man, that was the most vocab-y lesson of all time for a math class. Okay, now I want you guys to find the 5-42 resource page. Scoot your notebook over. Find the 5-42 resource page. Okay. Okay. So I'm going to help you do the first two, and then I'm going to help you classify them, and then I'm going to give you time to finish it. So if you could just, whenever you're ready, slide your notebook off to the side. Okay, so let's take a look at this first one. I'm going to use the same two colors I was using before. It's up to you. You can do whatever. Okay. All right, so I'm taking a look at A. And the first thing I want to figure out is, what is the growth? What is happening in this sequence? I know this is the easy part, right? It's going up by 3. T equals 3. Okay, I'm gonna pause right there. Everything looked good to you so far. I figured out that it was going up by 3. I filled in the rest of the blanks and filled in the rest of the table. Everybody clear on that? Okay, I know that this might seem like I'm going way too slow, but it's just because of the vocab, it's not the math. Okay, now I'm gonna go 1, -4, 2, -1, 3, 2, 4, 5, 5, 8, 6, 11, 7, 14. My dots made a line, so it is an arithmetic sequence. Okay, I'm gonna pause right there. Does anyone have any questions about what I did so far? Promise you're good? Double, triple promise? Quadruple promise? Like 47 promise? You're good? Okay, now I'm gonna get the other color. And I'm going to draw an arrow backwards and make a line. Okay, and that would be term 0. That will be the y-intercept if there was a y-intercept. Like a secret invisible y-intercept. I don't know if you guys know Mr. Jones's wife, Mrs. Jones. She used to call it the ghost term, like it was a little ghost, and she would draw a little ghost around it. That was super cute. But anyway, what would be the number in front of the -4 if there was one? -7. Okay. Okay, the last thing I'm going to do is find the equation. T of n equals, okay, so you might really want to write y equals mx plus b, but remember you're working with a sequence. So your y is T of n equals growth n plus term 0. So mx plus b. Okay, now that problem is done. They'll go fast once you get in the hang of it. I have bat ears. It's mom and teaching. I can't help it. Okay, any questions about A before we move on? I promise you they'll go faster after the first couple. I just want to be really careful. You guys good? You sure? Okay. All right, move on to B. Okay, what is happening in B? What's happening in my pattern? Times 2. Great job, person that just walked in. Catching up with the stuff immediately. Nice job. Okay, times 2. All right, so the sequence generator is R because it's a multiplier. So R equals 2. So you're going to have to think about switching that letter up when it's multiplying. Okay, so this would be 24, 48, 96, 24, 48, 96. Okay, and this time you have to fill in. So this is term 1 is 1.5. Term 2 is 3. Term 3 is 6. Term 4 is 12. Term 5 is 24. Okay, then graph your dots. Okay, there you can't fit them all on. That's okay. Remember, they're not all going to be able to fit on, but you can tell that it's making a curve. And it's making a curve, and this is multiplying by 2 each time, so this is called geometric. Okay, any questions so far? Now we have to do the hard part. That was all easy stuff. Now we have to do the hard part, which is take my other color, arrow back, find term 0. What would be in front of the 1.5? Yep, 0.75. And you could do 1.5 divided by 2 on the calculator if you wanted to. Okay. T of n equals. Okay, now this one is geometric, which means that it's not mx plus b. It's ab to the x. A is this. B is the multiplier. And then because it's a sequence, we don't use x, we use n. Okay, now what I want you to do is flip through the rest of them with your group. Figure out if they're arithmetic, which means you're adding each time, geometric, which means you're multiplying each time, or neither, which means that they're weird. So right in this spot on each of them, I want you to flip through, don't do any of the math, but flip through and write arithmetic, geometric, or neither on all of the rest of them in the. Okay, so arithmetic means it's adding each time. Geometric means it's multiplying each time. And neither means it's weird and not doing either of those two things. Just neither. Yeah. There's like a bunch of them. You're just going to put it's not one of those two. Take a minute, identify all of the rest of them in the packet as arithmetic, geometric, or neither. And you should find 3 neithers. My goal is for you to find 3 neithers. It's just adding a negative. Does anyone think they found one of the neither ones? What? You found 2? Okay. Anyone who have an idea of one of them that you think might be neither? Yes, Parker. E. E is definitely neither. Great job. Yes. C is definitely neither. One more. I. Okay. Now mark C, E, and I as neither. C, E, and I. Okay. Now for C, E, and I, you will not be able to find an equation. So, and you won't be able to really necessarily write the rule nicely. Like you're not going to be able to say like D equals something or R equals something. You have to just kind of write the rule in words. They're also kind of hard to figure out. So I'm going to give you some time because I want you to give them a go and see if you can figure them out. The other ones are not bad. So you can just go through them. But no, for C, E, and I, you do not have to find the equation. You can't. Well, you might be able to if you're a vegan, but you don't have to. And see if you can write out a rule in words. Even if you can just figure out the table, I'm going to be excited. So, okay, go ahead. Give them a go. Fill out of this as much as you can. I'm telling you. You want the way. You called the Fibonacci sequence. And it's from that one movie, but it's not really from a movie. It was in a movie, so like Nicolas Cage movie, where he's like going to like the murder mystery thing and the comparison with the lead. Anybody like he's got to break a bunch of codes to like save somebody's life. Not a recent film, I would say, but there's a book first. The book is way better. It's called. It's really good if you like puzzles and stuff like that. Oh, um, no, no, no. What the? No, no. What? 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 It's Nicolas Cage, right? Am I crazy? I'm crazy, huh? What's that? Oh, it's called the Da Vinci Code. That's what it's called. Let me go. Okay. And then this guy, your favorite. Okay, is there any other ones that you have any questions on? I should, that was improper grammar. Are there any other ones that you have questions on? Any of the other letters? You sure? Positive. I know those three were spicy. Okay, can you guys all please get your notebook open to the homework from last night, which was 35 to 40?